Okay, this is Openfire recording the first one. I'm not streaming this because I don't know how it's going to turn out, so let's see. This is my open source 3D printed flywheel blaster, and I just printed this cage, and now I need to design the pusher mechanism and magazine well so that it will fit up and match the cage and the butt plate, which is what I was just working on. So you can see these three holes that go through the butt plate, and they need to get matching holes to go into the cage. Wait, what? These should be two separate bodies. Why are they the same body? What? Alright, so I have a series of cuts and split bodies to separate all of the components in this, but they don't seem to be working. Okay. I made the body thicker, and then that cut didn't go all the way through, and so now those are separate bodies. So I'll make that one orange, and we'll see. Yeah, it looks decent. Okay. So remove the butt plate, and then this is the sketch that has those three holes, and we need nuts as well as the holes. Okay, so I want to change 3.2, making the hole bigger because in my last print it did not fit through. Okay, this is the state of the design at the point when the sketch was made. Okay, so the sketch was made there. Okay, the sketch looks good. I'm going to show that sketch and then extrude. I cannot select those right now. Nope. There we go. So I'm going to extrude these three. Offset plane. Let's say 100 millimeters. And then extrude them like that. And just tune this till it looks about right. That's a little close. Whatever. Okay. So then this one's irrelevant now. Objects to cut. Check the butt plate. Okay. And then we do that again with the hexagons for the nuts. Oh, is our selection filter off? Yeah, okay. So these 3 nuts need to be... Oh wait, we need the slots to be able to slide the nuts in. So let's draw those. Make a line, vertical, across, and then down. Coincident between these 2. And then, let's see, this one comes in from the bottom. The actual distance here doesn't matter much because there's no material on the other side. And that needs to be vertical. It keeps hiding the sketch and resetting my selection filter. Okay. So, why is there a line there? I can pull these lines out too. Okay. Just delete that one, and this, and this. And this is no longer properly constrained because it's no longer a polygon. Oh. So this should be collinear with this. This should be vertical with that. The angle between these 2 should be 120 because it's a hexagon. Okay, now let's repeat that. Oh wait, I need to set the vertical. Okay, so I can make these 2. How do I line this with the point I'm going to make? See, I want perpendicular. And so the triangle means it's going to the midpoint. I want to make this a construction line, and then that goes on there. And now you can see this turn black, means it's probably constrained. Okay. And if you're not sure, you can try dragging stuff around and see how it breaks. And then now you can't drag it, which means that it's good. Okay. set the angle. So many warnings. I should go through and fix those at some point. What? What is going on? I'm gonna make a symmetry line. Okay, so these two are symmetrical about that line. Okay. That should be fixed now. Let's try this again. So, extrude. Selection filter. I don't know what that line is from, but offset plane, which is not the best idea in the long term, but I don't really care at this point. Nuts are 2.5 millimeters thick. That looks alright. Oh wait, so 160 puts it there, so I'm going to put a 6 millimeter gap there. Oh, and I need an opening in here to be able to insert the nuts in. Okay. Back to the very first sketch. So, draw a box here. This line. What are these doing anyway? There's no point to these. Okay, nothing broke there. I'm gonna say 12 millimeters on the top. Make this a, sure, 20. This is mostly just weight saving. That dimension doesn't matter. And then, where was it? Somewhere in here. I'm trying to find the extrude that made the pocket down here. So, you can roll the history marker to different locations, and then I'm adding this box to that extrude, so now we have an opening there. And then if we roll the history marker to the end. Oh, now I remember why I didn't have this go down more, because you can see now this part is split in half and we do not want that. Okay, so this is going to come up a lot. And that's too high too. Okay. So that's like 16. I'm going to make this like 12. so you can see the slot for the nut. That's still going down more than I like. Okay, so 15 and 10, and then make this parallel. Why not? Alright, that looks decent. Okay, so there's one slot for a nut there, and there's a second nut there, and a third nut down there. Okay. So this motor's done. We still need to design the latch. Oh. Okay, I'm gonna go look up on eBay. Why is this in my bookmarks? I think that's what they call them. There's a bunch of different styles of these latches. I'm using a solenoid latch for the mag release so that you can actuate it with a button near the handle instead of having to actuate it near the back. Wait, I have a model of the latch. Here we go. I don't need to redo it. I think it might be in here anyway. Latch, there we go. Why is it orange? Steel, there we go. So since this is an asymmetrical part, we need to do this after the mirror and the combine. Okay. Okay, so that combine is broken. Let's do a new combine. Right now we care about these two. God, this looks so weird. Okay. Let's just fix. Alright, that looks decent now. Shut the cage. And then let's hide. So I'm clicking on each body and then it highlights the body in the list so I can go find it and then hide it. Okay. So this latch needs to go in there. Let's make a new sketch. Is that justified? I think we can do it in here. Okay, yeah, so there's already the beginning of the sketch here. no longer construction lines. Okay. And we need, okay, that's a 3mm hole. Let's see. So our options for retaining this screw are to either screw it into plastic or have an exposed nut on the outside of the blaster. I really don't like screwing into plastic. Okay. Let's go check the dimensions. So, no, that's not it. Okay, they are 60mm apart, centered, and the distance from here to there is 11.75. Rectangular pattern. So they are, there's two of them, 60mm, and two negative point negative 75 times 2. There we go. And then we can put a symmetry constraint on these two. Can we? Yeah, we've. Oh, it's gone. Okay. I'll put another symmetry line there. So you can see that triangle means it's on the midpoint of the line. Okay. These two are symmetrical at that line. Why is this so difficult for it? Okay, next up is figuring out how far off the center line this plane needs to be. So this is 10mm, yes, and then from here to there is 4, so the total distance from here to the midplane is 9. Okay. I haven't showed that. And then I'm going to extrude this, offset it 9mm. Well, let's see, which way do I want it? I guess I'll go the other way. Okay, negative 9mm. I'll just say to object that will join. And then I'll put a joint in the center of the latch to the center of. Wait, how do I do to the center? What? Alright, back up. It's really annoying how hides those bodies. Okay. So what we need to do is remove that to make room for the latch. So we add this triangle to this extrude. Now we can go to there. And then make a joint from on the latch in the center to there we go. That looks good. Okay, hide this stupid. Oh, that's the same body as the entire body before, and so that's why it's getting hidden. Okay, that's annoying. You can see the latch goes out into the mag well. Let's see, I think we need to fill it. We should put an angle there so that it can 3D print properly. So chamfer this. 2 distances. This one. Or I'll just say distance and angle. 45 degrees. Maybe I should just go all the way down. Why is it? Oh, because this is an angled surface. It's having trouble. Okay. So I'm going to use the extend tool on here. Connect this to that. And then why does it hate me? That's not really what I wanted. Okay. Wow, I was close. Okay, so there we go. And then we're going to go back forward. Oh, I have something in my eye. Okay, that's the right position. And when we do this extrude, we also want to extrude that. Oh, and then that breaks our joint. So let's start over with this joint. Let's say, what's the best? I guess the top. So that would be this side gets attached to the top center. This. And this is so annoying. Okay. That's not right. There we go. Alright. So that looks decent. I don't know what else is going back here. Oh. We could slide the nuts in. Let's see. So 2 nuts come in from the back, 1 comes in from the top. No. 2 in from the top, 1 from the back. 3 nuts should be enough to hold this. Okay. If we really cared, we could put another nut in through the mag well, but I don't care that much. Okay. So go to the sketch, and let's make some hexagons. I said 2 in from the top because that's a simpler 3D printing operation than bridging across. And there's not a whole lot of material to bridge across there anyway. So, very crude hexagon. Oh, we can use the same pattern, the rectangular pattern. Sort of. Because this one has to be rotated. Okay. Yeah, I am going to delete this, and then I'm going to attach these lines to that line. Why does this take so long? I should save in case it crashes. What the hell? Might as well go check Discord. What? Overconstrained. Come on. Seriously? Okay. So I'm just gonna drag these up. It doesn't really matter. So these are M3 nut over 2. I'll just set this dimension equal to that dimension. This is there. This. Oh, there's a better way than the midpoint. What the hell? No. Oh. There's a perpendicular constraint there. That's why I was over constrained. Okay. There's a better way than doing a midpoint line that intersects with the center. You can just specify the distance to be the same as that. And then if we set these equal length, is that enough? Come on, Fusion. Okay, that did work. So, rectangular pattern. these lines go over. I want 2 of them at 16mm spacing, so that goes over there. Let's see if we can get this on that line. Maybe. I keep thinking it's crashing, and it's not. That seemed to work. Why do you do this to me? Okay, so let's save in case it does crash. Okay, it's saved. Oh, we need to add. Let's see, what even is the point of this line anymore? I don't know. Maybe I shouldn't delete it. Yeah, I'll just make it a construction line. Oh no, because we need to extrude this triangle at some point. Okay. So, another ugly hexagon. So, it shouldn't be too difficult to slide these 3 nuts in. Oh, actually, getting the screws in is going to be the hard part. Maybe we should extrude holes through the side of the blaster to put a screwdriver through. Yeah, that's the way to go. I should plug my laptop in. That might help with performance a bit. So I also need screwdriver holes. So there we go. Oh, that's gonna be a pain because it's overlapping. Whatever, I'll just make a tangent. I'll set up this one. Okay, so circle is tangent to the line. There we go. This circle is equal in size to that circle. Oh, when it comes off above the edge there, I don't really care. Why is this blue? I don't know. What the hell? Oh yeah, that thing. That was pretty ridiculous. Alright. Let's see if I can go a little bit taller with this. Is this gonna work? Fusion, I'm totally not over constraining that point. You're allowing me to drag it. What? You don't need... Damn it. Alright, I'll just go... drag it up. I still don't know why that circle is blue. That means it's under constraint, but it shouldn't be. And this one is too. Whatever. Wait, what? This should be going out past the edge of the latch. Is the latch no longer lined up? Yeah, that's not lined up. Okay. So make this taller. Oh, because I went off the top there for my joint. How am I gonna do this? I need to... I can go off of the screw holes, because you can see those, the screw holes are still in the right position. Okay. Delete these. Okay, so that screw hole goes to... What? They're not even lined up. Oh, that's a parallax error. Okay. No, I don't want to select the sketch. Okay. So that hole. And then, oh, we can rotate it. There we go. Okay. That seems much better. Okay. And then I'm actually going to go before the joint to make this extrude. You generally want to go as early as you can. Let me show the sketch again. Okay. So profiles. And I can't select to the body. Okay, those 5, 1, 2, 3, 4. Why are you not letting me select? offset plane. When we go -9 is where that plane is, and then let's see, -6, and then minus. I should have a parameter for x naught thickness. Okay. Yeah, AV. I'll go watch that later. M3 not thickness. Okay. And so now these three should go in there. Alright. That shouldn't be terrible for assembly. I show that motor, and so you're gonna have to assemble the latch before you put it in the motor. Okay. That's what you have to do. What else do we need in here? So, those holes look pretty good. I should double check that spacing before I print this. Let's hide the sketch. And also some of these bodies. Oh yeah, hide the bodies. Alright. I think the jam door hinge is still pretty messed up. What the hell is going on with these? I also need to fix the side plates. This right side plate in particular needs some cutouts for the motors because they are positioned farther to the right here than I had originally anticipated. I was thinking about making this asymmetrical because you can see there's a huge amount of wasted space on this left side. And you can shave a little bit off of the left side here, but that's not a big deal. Okay. Oh, I should make a model for the motors. I have one for the flywheels already. Oh, I should hide that so you guys can see more. Okay, I'm gonna do the jam door now. So, let's back up before the mirror. Oh, this segment is a byproduct of how I did the split. God, splits are terrible. Okay, so, to show that, that's one of these. Let's see, what's the best way to show this? So I drew everything as one big body, and then I did that so that you can do things like the fillets between different components. I originally drew it with separate components, and just making these rounded edges like continue through all of them is a nightmare. I don't think it's even really possible. So once you draw it as one big body, you then have to split it up into a bunch of smaller bodies. So you can either do that through extrudes. You can extrude a very thin cross section that cuts the part in half, or there's this tool called split body right here. And so with that, you select like some sketch geometry, and then it goes perpendicular to sketch and splits it. But it goes all the way through, which is kind of a pain for some things. But I'm gonna hide this cage. Let's see, this really should be a full circle there. Let's go back. What's the best way to do this? So for this split, I split it along, I think it was this line. And so you can see this line continues up, and that's why we have the little weird piece up there. I need to figure out a better way of doing this though. I was thinking about doing it with an extrude. Because you need some space between the two halves at that point. Right, so since this is a rotating hinge, like, that's obviously not going to work because they're just going to grind on each other. So let's show this. Okay. And you can see here, I made a shell out of jam door, which unfortunately made this weird line on top. Was it the shell? I don't know. So if we go before the shell, oh yeah, there's still the line there. Okay. Okay, so then I put in the dart holding mechanism into the jam door. Oh, I also need to put a magnet back here, so embed one side in each. Okay, that should be fairly straightforward. I don't think I want to put it in from this end. That would be a pain. So, let's extrude this segment. Why is that missing? I was just missing from this part. So, when I make that part, I should select that. Okay. Let's extrude this and this, and hide that sketch. So this gets cut all the way through. Oh no, we don't want to do that, because that would cut here. So let's say two object there. And it doesn't like that. Two object never works well. If you change the two object to a distance, it'll automatically set to the right distance. Which makes me think, why don't they just do it in the two object? Anyway, So that's a little better. I think I'll also extrude that little triangle. And then you select the objects to cut. Okay, so this one is the top one there. I think this one's the jam door. Yeah, and then this one's the body down there. Okay, so we don't want to cut the jam door there, we want to cut this. That looks pretty good. We also want to continue. Okay, that was super easy. We want this to be a continuous smooth surface. We also need to take some off of the jam door in both directions. So I think that would be a top extrude. Let's try that. So make one rectangle here, another rectangle here, and put, say, 1 millimeter on each. No, I'm gonna make them equal. And make them collinear. And I'll put this on. I need to project this line and make this coincident. Okay, and so now I can show that sketch and hide the other sketch and change my selection filter. So 1, 2, extrude them up, and I do not want to cut that. What the hell is that body? Okay. There should only be... Oh, there's a little stupid thing at the top there. Okay. So these rectangles need to go more to the right. Okay. And it doesn't really matter how far they go. So, remove that. This line is only to be on that point. Come on. Okay. There we go. There are better ways of doing this. I'm just too lazy at this point in the design, which is not a good sign because I'm not actually that close to the end. Why are these one component? What the hell? Are they can't be split later. This is as far as it goes. What? Okay, so they're split here. And then I make the shell, and then I do a split, and then extrude. And so that extrude joins that. Oh, and then the way you hide it, or the way you have it not join, is by hiding it when you do the extrude. Okay, so now it won't join it. And then we can show it again, and now it's a different part. Okay. That's a cool trick I learned recently. Super useful. Now I'm trying to figure out what the stupid line is. I don't know. Anyway. So, go forward. That looks good. I think it's okay for these to touch here. Because they're not rotating. Oh wait, this is not good. So this needs to be cut around this circle like that, in order for this to be able to lift up. I feel like I had that in here at some point. Okay, so this lifts up, and then I'm going to try extending this and see if that's the right diameter. Come on. Okay. I think I'm going to make a smaller one. Give a little more clearance. I should really save. Alright, center point arc from here to there. Oh cool, I didn't make a tangent. What? I don't want that. Okay. This goes there. And the distance from here to here. Sure, 1 millimeter. What is the best way of doing this? Because this would mean it can't go up very far. Maybe I should make this bigger. Anyway, let's see how this comes out. So, extrude. This. And we don't want to cut the jam door. Oh, so I should continue this line so it creates a nice line there. Okay. But, oh, as for the actual, like, this line doesn't matter at all because we're rounding off the top. Okay. So, remove this coincident constraint. And then, why am I checking Discord? Okay. Extend this to there. I'm going to put this on there. Okay. What did I do? What the hell? Oh, God. is this split? Where is it going? No, no. I don't even remember where this went before. I think down here. Oh, because this line continues up. Okay, we're gonna have to undo that. So instead of continuing it, I'm going to make a separate line. Whoops. So if we make a separate line, hopefully that will allow us to turn at that spot. Make these collinear. Okay, and now everything didn't break. Sort of did. We don't want to extrude all of that. Or the middle there. Okay, that looks good. It's amazing how long you can spend with little tiny details like that. So, if we show the cage, then this looks like that. Hide this. These should not be touching. Why is the cage? The cage should follow this diameter. But I already printed it, so that's too late. Unless I take a Dremel to it. That's probably the way to go. Okay, what is this diameter? It's just 1 millimeter more than what the cage was. Why did I design it that way? This should be 1 millimeter on the inside. So this is a 7 millimeter radius. Let's go open up the cage. No, I think going smaller would be okay. Alright, let's see how much it breaks. Better idea. Just break the cage geometry constraint. Move the circles in, and then reproject the cage geometry. So if you hold down on a line, you can access the multiple different lines that are on top of each other. Okay, and then hide the cage. That looks good. So this whole thing needs to get 1 millimeter smaller. Let's see if it'll let us do that. Nope, that's not possible. Maybe because this is tangent there. That shouldn't matter. Is it this point? I don't know. Because there's no more projected geometry up here. Except maybe one of these circles. Let's see, what happens if we delete these? Do these turn blue? Come on. Yes, they do. Okay. One of these is then projected off the cage, so it's the smaller one. Okay. That hole needs to be bigger anyway. I don't really care. Put the smaller one. Okay. So this has 5 millimeters. Hope nothing breaks. Yay. So I'm going to delete that line, reproject the cage geometry. What? Okay. Project this. And then hide it again. Right, so yeah, so the cage should be the outer line. And this goes on there too. Oh, nothing crashes. Okay. Maybe this is not the right way to do it. First I'm going to say these two should be equal in diameter. And then concentric. No, that didn't work. What if I break this tangent? That freaks me out every time. Okay. Concentric. Maybe, come on. You could do it. Nope. If I break this, what? You don't have a bunch of math to do when I delete something. You just keep it the way it is. What the hell? Come on. What? What are you doing? What happens if... Let's just delete all these constraints and see if that helps with anything. Again, why? Wait, did I delete the wrong? Oh, yeah, I deleted the right tangent constraint. This line isn't even necessary anymore. There we go. Oh, the reason it was having trouble because this line no longer intersects that. Okay. I should have realized that because this line is tangent to the top line. Okay, so set those 1 millimeter apart. Let's see, can this touch there? Yes. Might as well just do that. Get out of the way. What? What is this point? There's 2 lines here. Why? I don't really care. Let's just stick them on this point. Okay, and this goes there. Okay. And this gets a tangent line coming up to there. Ah, what? What did I do? Oh, okay, so that's hidden. That's a little better. That still looks good. How do I just delete this body? Can I? Yeah, okay. Wait, that's not what I wanted. How about remove? There we go. I don't care about you. Oh, that's an interesting feature. Because this is no longer tangent. Okay. Let's see. The question is, will this rotate properly about that hinge? And I think it will. I would have liked to see the smaller one tangent to the top and the larger one come up above it, but it's too late for that with the cage already printed. And that would also put this hole closer to the top line, which is not very good because we're lacking material at the top. Okay. So I'm not even printing the jam door or this top plate. Is it even a plate? I'm not printing them now. I'm printing this piece. Let's put the spinner in though and see. Yeah, whatever. I just want to make sure the pusher works. So, the center of the spinner gets attached to hide the sketch. I want the center of that moved up 1 millimeter. Okay. And that's a little off. Oh, this should be roughly. There we go. So this is what's actually going to push the pressure, which I'm using a rapid strike pusher arm right now, which you can get cheap from Worker. And there's a screw going through here just for strength, because I was worried about this shearing off. I might switch to a 3D printed pusher arm at some point. We'll see. But pull that in a little. I don't remember what I put into the spinner dimensions. Oh well. So the idea is this is for the head of that screw, so otherwise it would hit here. And you also don't want it, you can't just raise this whole surface, because you need to push down on the pusher arm to keep it aligned properly. I thought that was a better solution than relying on the top of the screw to hold the pusher down. Anyway. And you see there's a hex for a nut there for the screw to go into, and then for the screw that goes onto the shaft, it goes in through that hole, and there's I should hide the sketches in the spinner. But you can see, where is it? What? There's supposed to be a slot for a nut to go in. Oh, I didn't put in this thing. I swear I did this. Oh, I picked the right sketch. The right extrude. Okay. That looks awfully close. Okay, that's better. So, you put a set screw into this hole, it gets pushed against this nut, against the shaft. Okay, save. Close this, update the spinner. There we go. You can still see one of the sketches. Okay. There we go. Oh, I should check that dimension there. Maybe not. I think this should do it. Yeah, okay. I I need to actually measure that on their abstract pressure and see if that's correct. Oh, we should save this. Okay. I think that was pretty productive. It's getting late here, so I'm going to go to bed. It's 3:20 in the morning, as you can see. Alright. So, this is the current state of Openfire. I think we're pretty close to being able to print this piece. Yeah, I have the hex heads in. I have the latch mounting plate in. I should probably do some lightning on this because it's going to take forever. It was going to be like 18 hours before I added this big block. I'll just print it with low infill. Anyway. Yeah. So, I still haven't decided on a color scheme. I printed the cage in orange. I'm thinking of doing yellow for the main part of it. Something like this. I don't know. Maybe. I feel like we should have some more orange in here somewhere. Oh, maybe the trigger. Alright. I'll figure something out. But this is a pretty productive session. We figured out the jam door and butt plate. Yeah. CAD is slow. Alright, see you on another one. This is Kelly Industries signing off.